But then he will be out of the frame.
Maybe that's fine. Like I'll talk here. Okay, I'll
You
come.
can maybe put it like this. The chair
Put it
comes in
like
front.
this and
Yes.
This one will work.
Okay. Yeah.
It's comfortable, right?
Yes,
Let's
yes.
sit once we can check if it's coming in frame or
Yeah.
not.
Maybe while writing the code, I will sit.
Yeah. Then you
I'll,
will
yeah, I can pull it. I'll pull it here. Wait.
Let's keep the chair here only so that even while sitting, people
Okay.
can connect with you. Yeah, Shashi, go ahead.
All right, now moving on to our next session, I'm delighted to introduce Dr. Abhishek Mishra. He's an intelligent cloud architect, a leader, and a Microsoft certified trainer with over 20 years of experience in Azure and .NET solutions. A published author, TOGAF certified, and the recognized Microsoft MVP, he brings deep expertise across cloud, development and machine learning. Today he'll be speaking on building RAG applications using LangChain, Python and Facebook AI Similarity research. Let's welcome Dr. Abhishek Mishra with a huge round of applause.
Thank you. So basically now, like we'll shift from business, leadership talks to some now technical points of POVs. So pure Python codings. How many developers are here? My tribe. Okay. So my tribe will enjoy now. Okay. So what I bring you today is, we had a lot of discussions about RAG. Who can expand RAG? What RAG is? Correct. Retrieval-Augmented Generation. So what exactly it is? We'll unlock it today. I'm not like FAISS, Facebook AI Similarity Search. So it's just like a vector database. I'm not going to dive much into that because I need to cater to all the audiences out here. And it's a hectic task for me to make the session in such a way that people, developers benefit, architects benefit, as well as the business leaders sitting out here also benefit. So I just want to keep everyone happy. I hope I am starting off with all of you with me, and I'm eager to see that all of you are alive with me till I complete the session. Okay, so let's get started. I'll quickly introduce myself. So I'm Dr. Abhishek Mishra, and we have already spoke. 20 years of industry experience, and I have published 4 books with BPB on Azure and 4 with FAISS, and currently I'm working on a 9th book on GenAI. Like it's on Microsoft Foundry, Azure Microsoft Foundry. I'm an Azure guy. My bread and butter is Microsoft technologies. And I've done my TOGAF as an architect. I need to survive in this talent pool, and this is, and for all architects, TOGAF is the way of how you can survive actually. So I've done that. I've done my MBA in operations and strategy, and entrepreneurship is my key skills, key areas. And I love talking to entrepreneurs. I love, I decide, or rather I help them with their go-to-market strategies, their branding. When an entrepreneur brings a product, how they can market it, how their operations will be. Because operations is the main essence of everything. You need to streamline that. So I help them in that. And I have done my doctorate in healthcare, digital transformation in the field of healthcare. So let's get started. Sorry, I keep switching. Okay, so this is the agenda for today. I will start with agentic architecture. So I need to tell you what agent, how does an agent looks like for programmers. We have seen agents, right? But how exactly to look for programmers? How will the programmers see this? Then, if we are doing some agentic programming, so how exactly we are going to build agentic programs? What is the basic, very basics, the bare minimum basics of agentic programming? So how the architecture looks like. So we'll see that. Then we will dive into two important concepts, RAG and model fine-tuning. Like maybe someone asked about when to use RAG, and if my data is changing frequently, what should I go for? If my data is static, how should I deal with it? So we'll unlock the answer to that using RAG and model fine-tuning. Then in the demo, I've automated the HR. No one likes an HR. And maybe to be very honest, I have to like HR because my wife is an HR. I don't have an option. But again, yeah. Okay. Let me see if I. Okay, sorry, I have just drag job issues. So, how does an agent looks like for programmers? When you are starting with agentic programming, what you need to do? The very first thing you need to learn is prompt. The prompt engineering. You need to write very proper prompts. So that is the basic. That is the very basic, very fundamental of any agentic application prompts. There are various ways of prompting. One is like you can create write role-based prompts where you can define a role. Like you can say, hey, LLM, any LLM, maybe ChatGPT or anything. I am a seasoned developer or I am an expert developer. Get me some code for this. It will respond to you with some like an expert. If just like some expert is actually responding back, some expert code it will generate. If you say I'm a novice, I don't understand, I'm doing it for the first time, so it will give you some basic code. Okay, so that way you can do the prompt. There are various techniques, zero-shot prompting, like where you don't give any prompt, like anything, write everything and dump everything to the LLM. You can give examples. They are called as few-shot prompting. So I'm not diving deep into this prompt engineering, but prompt engineering is something that you first need to learn. That is your starting point for any agentic developer. If you aspire to become an agentic developer or AI developer, so prompt engineering is the first thing. Next what? Learn the nuances of large language model. Okay, because LLMs are pre-trained. They are trained maybe like they will be running 6 months or 8 months behind the timeline. So you need to understand how to deal with the nuances of this LLM. Like someone asked about security. I need to manage the security, how the LLM interacts and all. Like the PII information, the guardrails and all, everything you need to learn. And one question, does LLM learns, like whenever you write to ChatGPT, does ChatGPT learns from your prompts? Yes. The answer is no. I'll tell you. Any LLM is pre-trained. Maybe it can capture your context, and based on your context, it can respond you back. But the large language model which is sitting behind your prompt, or rather, which is the basic engine, that is pre-trained. That doesn't get trained on your prompt. So that's why we get so many versions of GPTs coming. 4.0, 4.0 mini, 5.0, like that. Because the 5.0 has the most recent, it's trained on most recent data. And that's why the charge is like, if you see the cost, that is the reason. So these are the nuances you need to understand. Then the context memory. So you go to your chat GPT, you ask some questions. The next time when the chat GPT, you go back, you can still see what you asked for. And suppose like tomorrow again, like you go to the chat GPT and ask a question, it will answer you based on the context that it has, on the way you have interacted with it. Okay. So that's why we need memory. So they need to learn how to tackle the memory of the agents. And finally the tools. Tools are nothing but skills, what the agent is going to do. I have an agent. That agent is suppose it's an HR system, for example. So what does an HR do? They work on policies, they work on training, arranging trainings, they work on appraisals. So all these are HR skills. So all these skills are tooled. So maybe there will be various tools created and kept somewhere, and LLM will be calling all those tools. And the beauty of this tool is that, or rather this agentic programming is that they are exposed just like APIs. There is something called as Model Context Protocol, MCP servers. So behind the MCP servers, this tool sit. Sorry, I should have depicted here, but I wanted to depict simple. So this tool. The resource pooling is limited and everything is screwed up. There is no throttling, nothing. Everyone is calling anything. But this classic NXM problem, like everyone calling everywhere, is solved by MCP. Everyone calls the MCP, MCP is server. MCP server decides which tool to call. And this in this way, you manage the pools, the connection pools and all. Okay. Now, okay. Now the most important thing is the agentic programming paradigm. So suppose you are writing any agentic program or any Gen AI program. What are the primary components? Definitely a prompt, an LLM. We have understood whatever prompt you will give, LLM will work on. So in program also we give prompt to the LLM. We call the LLM and give the prompt. But on top of that, we also do few more things. That is output parser. So whatever LLM responds back to you, you need to present it in a readable format, right guys? So whatever you get, that should be in a readable format. I can interpret it and I can actually get to know what exactly it has responded and I can present it very well. Okay, so that is why we have output parser. And one open question, you must have heard about agentic frameworks, Microsoft Agent Framework, LangChain, LangGraph, AutoGen, Crew AI, so many frameworks has come up. Why do I need a framework? I can write, all these LLMs are API. I can call the API and I can get my job done. But why frameworks?
Nodes.
For the? Okay, orchestration, nodes.
They decides.
Okay. Okay, but that thing I can write in my program, right? I can also orchestrate in my program. The answer to this is, when you use a framework, your life becomes simple. Maybe as an architect or maybe as a business leader. Whenever you get a business problem, maybe for leaders when we get a business problem, or as an architect when you get a scenario to solution, what is the first thing we pick? What is a tool for an architect or a business leader? The framework. We try to impose a framework. Mera product nahi bik raha hai. My products are not selling in the market. What I will do? I will put some go-to-market framework, some lens to it, and I'll check why it is not selling. Maybe I'll check for the break-even. Why is my product is not breaking? Is not doing a break-even? Why is my contribution margin is not in place? So you will impose a framework, right? So with that framework, you will be able to handle the things. The same in programming also, or for an architect, when you give a framework, the framework handles all those complexities, orchestrating, like calling the LLM APIs. The output parser comes out of the box. So you need not write much of program. Just need to simply call the utilities from the framework and get your job done. Okay. So now, the most important question, the Retrieval-Augmented Generation. Okay. So I have some time, right? Maybe 10 minutes, 10-15 minutes I'll take.
All the time, sir.
Okay. Thank you. Okay. So Retrieval-Augmented Generation. So it will answer a lot of questions that we had today. So normally, when we just forget this RAG pipeline for now, I'll talk about it. I told you LLMs are pre-trained, but your organization is a living organism. I treat, whenever I go for any business consulting, the first thing I tell my customers, organizations are living organisms. They change. what is the nature of a living organism? They change, they adapt to the market scenarios. So Iran mein war hua, there is a war in Iran. So quickly we need to adapt. The organization needs to shape up and come up with strategies. Trump put some tariff. So we need to come up with strategy to handle that tariff. So organizations are living organisms. So your business scenarios are always changing, and a pre-trained model will not suffice. Correct. Because it has some old data 6 months back. How am I going to get the right context to it? The answer is RAG. Definitely fine-tuning is also the answer, but there is a architectural decision when to go for what. So when we go for a RAG, Retrieval-Augmented Generation, so what will happen is the user will give a prompt to the agent. Okay. So this agent will go to this vector database. We have I'll tell you how the data comes to the vector database. So the agent will not directly go to the large language model. Your organization context, the latest data, everything latest is stored here in this vector database. This vector database has everything, like anything that you want to use, maybe company policy, company documentation, everything is the vector database. I'll come to this part in a while. So the agent will go there, get the information, then pass it on to LLM. And it will tell the LLM, hey LLM, don't generate information based on the data you are trained with. Rather, generate it with information that I passed you from the vector database I have. Use my context, pull my context from here and give it to the LLM, and let LLM use my context, not the context it is trained with. Okay, so that is how you supplement it to work on the data that you have.
Is this not we're trying to make it learn with the new context?
Yes.
You cannot make them learn. It's pre-trained.
Yeah, we are not here actually. Exactly what we are trying to do here is we are making our agentic application learn the context, but LLM is not learning the things. LLM is just generating the information out of it. It is just switching the context, not from its pre-trained data. It will switch the context to this database. So it will generate the output from this vector database.
My context changes, won't my output also change?
Yes, it will change. That's why, like whenever the context change, we have RAG pipelines. I'll come to this. Every fortnightly, like the RAG pipeline runs, it keeps on updating the information in vector database. So like your LLM will refer to this vector database to generate. Basically what's a LLM is, normally any GenAI application, by definition, any generative AI application is nothing but that generates new content, right? Text, and its job is to generate, and it has a context, but we are switching the context to this vector database. That's clear, right? Swati, you got it? Yeah. So now, putting the data in this vector database. So you'll keep the data somewhere in the blob storage, or like I'm from Azure background, so I keep telling these terms. But somewhere you keep your data. That data will be read. Then the data will be broken into smaller pieces. Like you have 100-page PDF. The PDF will be broken into maybe smaller chunks, maybe 2 pages, 3 pages. Then like an embedding will happen. Embedding is nothing like you are encoding those splits in the like latent space. I'm not getting deep into this. Forget about the latent space. So it gets encoded into like machine readable numbers, 101 digital format. Okay, then like in binary format, and then like it gets pushed to vector database. Then like and this search is not a SQL search. It's a different search. What it is called? Semantic search. Correct. It's a semantic search. Semantic search will search on like your 1 zeros, your machine readable data.
Solution. I'm not from a very technical background. I can SQL like Python, but the example that you gave is PDFs, right?
Yeah.
What if I give him a database which is basically let's say sales data
Yes.
across regions and multiple tables?
Correct.
So even then it will going to break
Yes.
it or split it into chunks and then
Yes.
create a vector database?
Yes, it will. Because that's the challenge is, so you can't embed the entire database at short. If at all you embed it, so what happens now? There is something called as positional encoding. So, if you show the picture of a dog and you ask what it is, then it will say it is a dog, or it's a cat, or it's a mouse. Some animal it will say. How it infers what you are asking for? It's through the positional encoding. What is this animal? Then it will break this text into smaller piece, keep it in the positional latent space. Then the nearness is computed, and then a context. It will understand the context out of it. What the user is asking. What is the NLP is all about. Earlier days, if you have been an AI programmer, like it's all bigrams, you must have heard about bigrams and all. So it's not doing any bigrams or anything. It is just splitting your information into latent space. Then it is like circling with the nearest possible neighbors, and it is trying to get a context out of it. The context engineering nowadays we call, like, very popularly, the word coined, the context engineering in the industry. That is what it is doing.
Sir, is there any way to reduce the latency of this?
Yes. The answer is agentic RAG. I don't have a slide for this. Maybe sometime we can discuss. So what is happening is the center process is being taken over by agents.
And all this is coding or a UI based infrastructure?
No, it's both.
It's both.
If you are going for Azure AI search, so you will be surprised. You just give your PDF and you get your semantic search already. Indexes are built and your semantic search is set up.
Okay.
For a better example, the Google product that which is LM Notebook.
Okay.
That is also a major RAG product. Like if I feed a PDF on it, I ask a question on it, and it will give the question also, and it will answer the question also with the proper
Exactly. That is exactly what this AI search, Azure AI search does. So, like nowadays, Google, Azure, so they have implemented there. You just feed it and you do it. But normally, in industry, what I've seen is LangChain is the most adapted. LangChain, LangGraph, like a lot of developers are fond with this. Microsoft Agent Framework is picking up, trying to catch up, and all these splitting, embedding, everything like.
Okay, so this is the basically that framework that you're talking
Yes.
about, like LangGraph and LangChain, Creo AI.
Yeah, they'll help you with all these things.
All these things, okay.
So you'll write very little program and you'll be done. I'll show you actually. Just pass on the context. So I'll show you the code.
I'm waiting to ask you simple very question from the very beginning.
Okay.
So if I have to develop an agentic AI or an AI agent for my work, how much coding do I need to do? In
The
today's
answer
world?
will be relative. I'll tell you why. As a Gen AI architect, whenever a problem comes to me in my organization, whenever the very first thing that we do is we try to see what is the solution. I operate within Microsoft boundary. I first go for Microsoft 365 Copilot.
Okay.
Because there are no coding, only prompts. That is the first option. Hey, this Microsoft 365 coding pilot, let it tackle. I won't go for any programming framework for the sake of implementing something. I don't want to waste my customers' money. That is the first thing. The very second thing that I will think of is, is it a problem related to the developers? Is it some code I need to generate? Then I will think of pair programming kind of scenario where I will go for GitHub Copilot agents. Okay, so there also I can write prompts. I can create my GitHub agents. I can write prompts. I'll get going. There is if there are complex scenarios that cannot be handled by these two, then the third scenario is I'll go for a framework. But first, I will never go for a framework. I'll try to, because see, it's all about faster time to market, cost, because whenever you are building product, before a competitor launches that, you should launch it. Or else you are behind. There are two things to it. Either you will succeed. If you will succeed, your success, the initial success will define your product trajectory. Any product in the market goes through an S curve. It starts and matures and then it stucks. then it starts declining. Then you need to immediately define your S curve so that you keep your profit coming in. So you cannot wait for things to happen. So you have to build it very fast. Okay, just go ahead. So I spoke about RAG. Maybe this is the last slide, then I'll go to the program. So now let's take a look at fine tuning. RAG is fine. If your data is changing, then you do it RAG. Fortnightly, you keep updating your vector databases. You are sorted. But think of a scenario when my data is static. Maybe like the intent of your organization social culture, the social fabric of your organization, your maybe for example the hierarchy of your organization, unless there are nowadays companies, they reorg a lot. If you're not doing a lot of reorgs, it's a hierarchy and you want to feed it to your LLM. So in such scenarios, if your data is static, go for a fine tuning. It doesn't change that frequently. So what you are going to do is, when you are doing a fine tuning, I told you these LLMs cannot be pre-trained, but they can be supplemented. So with fine tuning, what you are doing is you are bringing your data and you are training your large language model with this data. So what happens is, this on top of this LLM, it is not going to rewire the entire LLM actually. Because when we talk about trainings, there will be weights, there will be so many parameters, millions of parameters and all. So it's not that easy to train this LLM. You need huge infrastructure for that we can't afford. For that, but what happens is, during fine tuning, only a part of it is trained, only the relevant weights or relevant parameters are trained, a new layer adaptive layer is added to that. That is something that LoRa does. Whatever the add-ons, you add it. I'll give you a nice example, pizza breads. So you get, normally this is what my 7-year-old daughter does. She gets pizza, she doesn't like the toppings, she'll scrap the toppings and then she'll put her own sauce and whatever she wants and she'll eat. So in the same way, she's rewiring the entire pizza. What if Domino just gives me, curious kids like mine. So Domino can just give me a pizza bread with all the Domino's goodness. She can bring her toppings, put it, and she can enjoy it. So here actually we are just putting the add-ons to it. Another way is you string the model. You don't have much of RAM still to train using a LoRa technique. You go for a Q LoRa. What I will do is I'll string the the LLM. I'll make the LLM very small. Okay, I'll shrink it, and then the stringed LLM I'll train it. That too, same thing what LoRa does. I'll just put the add-ons. So what is the advantage? Less memory. So as a GenAI architect, if someone comes and asks you, I need to fine-tune my LLM, what is your strategy? Your question is, what is your RAM, what is your infrastructure available first? And what is the amount of data? You just check the RAM consumption, memory consumption, your infra compute and all. Then you train it and you do it. And also Microsoft offers supervised fine-tuning methodologies where you can give key value pairs to the LLM using LoRa. I think they use QLoRa, LoRa, I just need to check. So one of these techniques they use, and they do a supervised learnings with key value pairs. They will train it. In direct preference optimization, what they do is Microsoft, they say that one question can have a right answer and a wrong answer for your perspective. Give both the answers and train it. And the third perspective is reinforcement fine-tuning. In case of reinforcement fine-tuning, what happens is, it's just like reinforcement learning. So if the LLM is, after you have trained it, it will go through cycles. If it has done the right thing, reward it. If it has done the wrong thing, penalize it. This is how the system will learn. So with this approach, and this is something I've already explained, LLM distillation. There was a question if data, I think you asked, right? I think you asked data issues. How am I going to remove noise? So there is a way where we can actually transfer knowledge from a larger LLM to a smaller LLM. Through this LLM distillation process, we get the seed data, pass it to the LLM. LLM will generate the synthetic data. We pass it to a small language model like Mistral or something. and then you get a distilled model. An example can be your case you gave the noise. I have a noisy data. I want to weed out the noise. I'll give it to the LLM. What this LLM will do is it will remove the noise and get trained on that data. From there, it will generate a synthetic data. But again, you have to every time human has to be in loop. So somewhere using some automations or some pipelines to check it, give it to the SLM, then you get your digital model.
Is it better to do LLM plus fine tuning or making another SLM?
LLM plus fine tuning. But in that case, what will happen is your LLM itself is a large language model. In fine tuning, what we are doing is a part of the knowledge we are transferring.
Okay, but can't we do it and make another SLM that will
Yes, you can just take out a subset.
Costly to make an SLM, which one is more costlier? That LLM plus fine tuning or the SLM part?
LLM plus fine tuning, see, both will, SLM is anytime cheaper because you can run it anywhere, but LLM will be costly because you are going to call the APIs and all. But again, cost aspects we need to check actually honestly based on the scenario, amount of data, how much we pass. So there will be different dynamics to it to deduce it actually. But that can be a technique, from the LLM you transfer it to a smaller LLM and distill the LLM. But mostly fine tuning, to your point, I have seen models getting fine tuned on SLMs mostly because they are smaller and easy to train. Okay, so with this, I am going to she's an HR, and I will automate the HR. I'll create a virtual HR. So normally I have picked up the policy. Yeah.
So what is the key difference between the agentic RAG and the RAG?
See, a RAG is
Easily implementable if you want to implement in real life.
I think if you ask me honestly, I'll say RAG because I've been doing RAG for long. But agentic RAG is the way to go. I'll tell you the difference. In RAG, to what I will show you today is RAG. The application will show you. You need to write your program. You need to do all these steps. You need to split it, chunk it, and do those things. But in agentic RAG, it's all these things are handled by the agent.
So if we really want to reduce the latency, then you told that we need to use the agentic RAG.
Yes.
So is it easily implementable?
Yes.
So what are the methods?
Even I've also not zoomed much into that area to be very honest. But in Azure AI search, all these agentic AI is already it's picking up. Maybe sometime I'll just I can have a multi-session in fifth IR. You guys can keep following. I keep doing sessions in fifth IR. I can do a session on agentic RAG.
So basically, the RAG pipeline
Is replaced by an agent. Okay. So now I have some privilege to sit. Normally, at sessions I do, I don't get to sit. Thank you, multi-cloud, for you for this. But the screen is visible, right? If I sit, I'll do it pretty quick.
Sir, is it possible for you to move a little to this side so that people can clearly see it in Teams?
Okay, but I won't obstruct, right? Anyone? No. Okay. Visible for all, यहाँ भी दिख रहा है ना? Okay. So, how many of you are Python programmers? Okay, cool. So you must be understanding this .env file, virtual environment and all. I'm not getting into those Python concepts. I will directly take you to the RAG HR chat app that I built. Okay, let's close this. Okay, so what this application does is, it does a RAG, RAG pattern. It uses LangChain and FAISS. Using FAISS, what I've done is I have implemented that RAG pipeline, and you can see here this is the vector database, index.FAISS, index.pkl. Whatever is there in this FAISS index, this is your vector database. Your vector database is here. Okay. So it's a very small database, so it's fine. I have kept it in the system. But there are also other industrial vector databases that normally comes, like maybe that are paid. But this is a free, like a community package, so we can use it. Okay. So LangChain is a framework. Okay. So there is something called as LangChain expression language. You remember I told you the components of or the programming paradigm of any agentic application. Prompt, LLM, output parser. Okay, then the output comes. Using LCEL, I can build this chain. So let me show you those things. Okay. See, I have already like deployed a LLM with guardrails implemented in my Azure, and I'm reading the OpenAPI key, the key for that. Okay. And then what I'm doing is like I'm loading the vector store from the disk. Okay. This is the vector store. I'm loading it here because I want to pass it as the context. But again, this is a small application, so I have loaded everything. Ek saath mein I have loaded everything, or else your application will crash. We should not be doing this. Then here I am actually initializing my LLM. Okay, and then a temperature. Temperature is a very important thing in when we deal with agentic applications. How many of you guys understand temperature? Yeah.
It's controller hallucination.
Okay. Yes.
The response.
If your temperature is less, then your model is deterministic. If your temperature is high, then your model is probabilistic. So whether you want to be deterministic, like want to do what exactly you have to do, or you have to be a bit innovative. If you are building a marketing campaign. So the product I showed you, like Retro, right? So the entire marketing campaign is driven by ChatGPT. High temperature, even it's high temperature on the floor, as well as we are having high temperature with the GPT. So any GTM is like that, like honestly, any go-to strategies for any product that you build, it's always high temperature. Okay, so you control the randomness here, then you create the RAG chain. So let me show you the RAG chain actually. This is the prompt. I told you you'll need a prompt. I showed you LLM. I showed you the context data. And this is the prompt. Your role is to help employees understand company policies. This is the policy document. Maybe I'll just show you that document. Maybe I'll open it here. No. One moment. Revealing File Explorer. I know you guys are hungry. I'll try to do it quick. So this is something like I've generated it using AI. So my startup toolkit is the community that I run and human resource policy manual. There are some policies that are defined. What I've done is I have did a RAG pipeline, and I have put everything in a vector database. I'll show that as well in a while. So I have created the prompt. Now let me just go to the application back, and I'll show you the chain actually. See, chain. Okay, see, first I am in the chain. I'm passing the context from where my LLM is going to search the information. This is the place retriever. So where actually I have loaded my RAG data, which is there in FAISS folder. Okay. Then the prompt. Okay. Then I am giving the prompt, the LLM, and then I'm using the output parser to format the response that it is coming. It is the same paradigm I'm talking about. Any framework you take in GenAI. So this is going to be the steps. as of today. I don't know what happens tomorrow. Things are very fast changing, but these are the steps that will happen. Now, let me show you how I have created the vector store. If you see here, I think set a vector store, yes. Shashank, we spoke, right? The guy we are. Just connect with him. Yeah. So, here actually, you see here, we are setting up the vector store here. We are passing the path and using the framework itself. I'm not writing any complex code out here. I'm just using the framework like PyPDF loader. Okay. So with the PyPDF loader, I am splitting text into chunks here. I told you I need to chunk it first. I'm splitting text into chunks. And then what I'm doing is I am using the text splitter and all, I'm defining the chunk size and I'm actually splitting it here. Then once I have got the chunks, then what I'm doing is I'm creating the embeddings out of it using OpenAI embeddings models. Embeddings are nothing but they will assist you in semantic search. So I need a OpenAI model to do that. So I'm using one of the embedding models and I have done the embeddings. Then once that is done, then your OpenAI embeddings are loaded in this database. Now, let me quickly show you the demo. What I've done is I've already created a test file, and that is the way we test GenAI applications. We don't write prompts and manually keep testing it. We build a test pipeline. We define a set of questions. That's what I've done here as well. We define a set of questions and we run that pipeline and it keeps asking the questions and keep generating the responses. So this is what I'm going to do. What is the file name? Demo. Demo.py. Okay. Hopefully I get it. Yeah. Loading. See, it's loading the embedding models. I am using a cheaper 3.5 Turbo GPT, old one. And now the first question, what is the PTO policy for employees with 3 years of experience? It is responding back from the knowledge base, from that PDF. Employees with 3 years of service of Startup Toolkit are entitled to 20 days of paid time off. If you see the PTO policy here, maybe. So if you have 3 years, then it is 20 days. That's what the LLM responded. Right, very 20. Okay. Now I'll just, let's see what's the next question is. How many sick leaves do employees get? Employee will receive 10 days of sick leaves. Everything it's reading, giving you the answer from the policy document. See, this is the most famous or the favorite question for all of us to HR. What is the remote work policy? At least I ask, even Swati, you must be also asking. So all of us we ask. So this is the remote working policy. Then tell me about your parental leave. So there is some parental leave policy also defined. What are the company's working hours? Very important question. So it calls out 9 AM ko pahunchna hai, 5 PM tak we have to be there, and there is a 1 hour lunch break. Something like we have today. Okay, but however, specific schedules may vary by department and position, so employees should consult with their supervisor. The golden disclaimer we give every time when HR frames any policies.
This is due to that creativity, right?
Sorry?
This last part is due to that creativity, or it was in that file?
No, it will be there in that file actually. It won't actually, it will create, it might have even created, we need to check that. But whatever it has generated from that file only. From that file we we put it in this FAISS index
The
folder.
language that it is using is not the exact language coming from the PDF.
Yes.
It is actually generated
Generating
by the
it.
LLM.
Yes. So that is what LLMs are meant for actually. So LLMs, like any GenAI applications or LLMs, they are meant to create new things. Right. So like it's creating new things, like it is just reading the context and it is generating new content.
Can it?
Yes, yes, you can. If you want, if it will be there in that document, then it will answer
Can
the
it
context.
also create charts and everything, or is it just content?
Yeah, charts.
Charts can also create.
Yes, yes.
LLMs.
Yes, you can. It's ChatGPT, like ChatGPT. Normally, like they're the
Normally, do they create like if there is a data in the PDF, right?
Huh.
Or let's say I'm talking about a database and I'm asking some question in a prompt.
Huh.
Will it be able to give me a chart
Yes.
representation, right?
Yes, yes, everything, like the way you program it and the way you tune it.
So in the prompt, we need to mention.
Yes.
That, is it we need a flowchart or something?
Yes.
So this is something for developer, right? Who is
Yes.
testing it? For
Yes.
a business person or a user, how do you deploy this so that end user can use it?
Deployment is a big story. I'll tell you how. Normally, when you have your application ready, you have tested it. So normally we do it in the local environment. But when you are productionalizing it or industrializing it, then scenarios change very fast. You have to make it secure
Yeah.
and all. So first, like where you want to put your this application. I have showed it in console, but you need to figure out the right place to place this. So for that, you need to first figure out. Yeah, like we have a Neo agent, correct, exactly. So in our office, we have Neo agent that helps in this kind of things. So we can have our, we can keep it in Teams or on a website. Somewhere you need to keep it. That is the first thing you answer. The second thing is the operational aspects, what it is doing with your data, your prompts. For that, you have to see that you have the guardrails. Is the data, what is the DMZ of your data? Like demilitarized zone we say, right, in networking. So uske bahar, like it gets public or gets into another zone. So those things are there.
Can we see the demo?
Sorry?
Could we see the demo file?
Demo file, okay. Demo file will have bunch of prompts.
The right questions, we don't get the right outputs.
Yes.
Like if we are again and again putting in some prompts, we're not getting the right output. Like dissatisfied with the performance because we are not knowing how to get answers from it, and based on that, it's not responding.
We need to capture those instances actually. It did not work, all this, like it won't capture. And
Same popularity, like it will say that you learn my language only, then I can answer you based on what you want.
so we'll have again
that
like,
language, I'll not typically use it. So how will this tool gain popularity
okay.
if I don't know how to do prompt engineering?
Okay, like, no, I get you. Like, you want to say that prompt engineering, if someone is expert in prompt engineering, they can get the answers very easily. But see, to be honest, like, prompt engineering is done in the program. Okay, but prompts are normally user natural language. That is how it's meant to be. Like we speak, we are speaking in the same way, like, you should be asking the agents.
But it takes a while for this agent to understand exactly what we need. All the data it collects, it asks a few questions from us, maybe 5 or 10 questions, and then it gets to the exact.
Yes, because it gathers the context around it. It has a memory, right? A sodium memory component. I didn't build there are LTSM, short-term, long-term memories. So I didn't show it in the demo, but with the memory, you can keep building the context and their agent will become more better and better.
I think there are agents that can help us give us direct prompts for our layman language. They will be input them.
Exactly.
They provide us very good prompts.
Correct.
So we will use that.
So there are different techniques to make the agent better and better. So it will evolve with time.
Testing environments where we have tested it for like 5 questions, but अगर
Okay.
इसको production पे डालता हूँ,
हाँ.
then there are like multiple scenarios, multiple test cases that are required.
Yeah.
उसको monitor कैसे करेंगे?
उसके लिए ना pipeline बनाना है. वो pipeline में you put all possible, you ask the LLM itself to generate questions. Keep building. See, this is a test pipeline. Okay.
So, but how I will like monitor the output of it? क्या
हाँ,
output कितने लोग हैं?
हाँ आउटपुट भी उसको नहीं क्या हाँ उसका आउटपुट मतलब वही LLM को ही पूछे कि क्या जो दे रहा है इज इट वही एनीवेज जो आप करोगे तो यू विल आस्क LLM टू टेक दिस कॉन्टेक्स्ट फ्रॉम दिस कॉन्टेक्स्ट टू क्रिएट क्वेश्चंस एंड आंसर्स एंड जस्ट चेक व्हाट इट इज आंसरिंग.
Will it not become an infinite loop? Like we are asking him to create questions as well and then answer itself, right?
Answer and yeah, there will be also human monitoring will also be there because test results आपको monitor भी करना पड़ेगा ना. So you'll have to monitor what it is responding. See, definitely in वो जो that paradigm like everyone says that it is going to be like everything will shut and all will be developers and all. It's not going to be this. It is definitely like human will be there in the loop. So this is few of the questions that I have given here in the demo. I think you wanted to see the demo file, and I'm simply calling the chat application. Okay. So a lot of things, if I keep speaking on this, it will be, you all will skip lunch. Then Anjani will not have any agent camp in future.
Okay, so let's have the lunch because one of our speaker from Italy was voting.
Yeah,
So
it's done.
we have given him time around 3. So he is a legendary master. He has a plethora of experience in the retail world. He gets the Bata retail platform. He will be joining us at 3 p.m. Let's have a lunch